All right, so today we're going to really take a deep dive into something that could completely change how we understand the universe. Expansion. It all started with a bang, and it's still expanding thing.
Right.
Well, some researchers are saying, hold on, not so fast.
Really?
They've been looking at supernovae, and their findings suggest our current model might be missing a big piece of the puzzle.
That's interesting. So what are they what are they looking at specifically?
Yeah.
With these supernovae?
There's this paper, Supernova Evidence for Foundational Change to Cosmological Models, by Seifert and his team. And they're suggesting that instead of this mysterious dark energy pushing the universe's expansion, it might be the structure of the universe itself.
Wow. So you're telling me we might not need dark energy anymore?
Yeah.
That's a pretty huge claim.
It is a huge claim.
Can you even explain dark energy to me? Like what even IS it's supposed to be?
Right. So imagine a force that's the opposite of gravity.
Okay.
Pushing everything apart rather than pulling it together. That's the role dark energy plays in our current standard model of cosmology, also called ΛCDM.
Right.
And it was introduced to explain why the universe's expansion seems to be speeding up, not slowing down, as you might expect.
Okay, yeah. So we basically invented this dark energy thing to make the math work, but we don't actually know what it is.
Pretty much.
Okay. Interesting.
It's one of the biggest mysteries in cosmology.
Yeah.
Now, this new paper proposes a model called the Timescape model.
Timescape model.
And it suggests that instead of this mysterious force, the uneven distribution of stuff in the universe, galaxies clustered here, vast empty spaces there, could be creating the illusion of acceleration.
Wait, so you're saying the universe is kind of lumpy and that lumpiness affects how it expands?
Exactly. Think of it like a loaf of raisin bread rising in the oven.
Right.
The dough expands, but the raisins, they stay put.
Right.
Now imagine some parts of the dough rise faster than others.
Okay.
That's kind of what the Timescape model is saying, the voids. Those empty spaces might be expanding faster, while the denser parts with all the galaxies are expanding slower.
Okay, that makes sense. But how did they even figure this out?
Well,
what's so special about supernovae?
So supernovae, specifically type Ia supernovae, are like cosmic light bulbs with a known wattage.
Okay.
They explode with a pretty predictable brightness, and that makes them incredibly useful for measuring distances in space.
So it's like knowing the wattage of a light bulb and then judging its distance by how bright it appears.
Exactly.
Got it.
So they're using these supernovae to measure how fast different parts of the universe are moving away from us.
You got it.
Okay.
They analyzed a massive data set of type Ia supernovae.
Wow.
Called the Pantheon Plus dataset.
Okay.
And they used a new statistical method that they say is much more accurate than previous approaches.
Okay. And what did this super accurate analysis reveal? Is it really saying goodbye to dark energy?
The data strongly favors the Timescape model.
Okay.
Especially for the parts of the universe that are closer to us.
Okay.
And get this, it even holds up when looking at distances beyond what we consider statistically homogeneous.
Hold on, statistically homogeneous is? You're going to have to explain that one.
Sure. So imagine zooming out from Earth way, way out.
Okay.
At some point, the universe starts to look pretty uniform, like a smooth soup of galaxies.
Okay.
That's statistical homogeneity, the idea that on a very large scale, the universe is pretty evenly spread out.
Got it.
But what's interesting is that even beyond that scale where things should be pretty uniform, this new model still seems to be a better fit.
So we've got this new model that might explain the accelerating expansion without dark energy.
Right.
And it's holding up even in the really far out parts of the universe.
Yeah.
That's a game changer.
It really is. And what's fascinating is this model doesn't just change how we understand the universe's expansion.
Yeah.
It could rewrite our entire understanding of its evolution.
Wow.
Yeah.
Okay.
Yeah. Think about it like where we are in the universe. Our little corner of the cosmic web could be affecting how we see things.
You mean our view of the universe is like looking out from a specific window and someone across the street might see a slightly different view?
Exactly. Their window might be facing a denser part of the cosmic web, while ours might be looking out into a void. And that difference in perspective, according to the Timescape model, can actually affect how we measure the expansion of the universe.
So this timescape model is already blowing my mind.
Yeah.
But you mentioned earlier that it could change how we think about the entire evolution of the universe.
Yeah.
What do you mean by that?
So the standard model, the one with dark energy, it assumes the early universe, was incredibly smooth and uniform.
Okay.
Like perfectly blended cosmic soup.
Right.
But the timescape model, it's a bit more rebellious. It allows for the possibility that the early universe wasn't so smooth after all.
Oh.
It might have had its own lumps and bumps, its own unique texture right from the start.
So instead of a perfectly smooth baby universe, we might have had a baby universe with some wrinkles and dimples.
Yeah, that's the idea.
Wow.
And those wrinkles and dimples, they could have grown into the large-scale structures we see today.
Okay.
The galaxies, clusters, filaments, all part of this grand cosmic web.
So those early imperfections could have shaped the entire universe as we know it.
It's a wild thought, right? And it raises so many questions like, how do those early structures form?
Yeah.
How do they influence the evolution of galaxies? Did they play a role in the distribution of dark matter?
Right.
Suddenly there's a whole new layer of complexity to unravel.
But wouldn't we have noticed these early lumps and bumps before? I mean, haven't we been studying the early universe for a while now?
We have, but our tools and methods are constantly improving. Remember, we're talking about the very early universe, billions of years ago.
Right.
It's incredibly faint and distant.
Yeah.
So it takes incredibly sensitive instruments and clever techniques to probe that far back in time. And it's possible that some of those early structures were just too subtle for us to detect until now.
So what you're saying is the timescape model is not just a tweak to our current understanding.
Right.
It's a potential paradigm shift.
Yeah.
A whole new way of looking at the universe.
Precisely. It's like we've been wearing blurry glasses, and now, with this new model, we're putting on a pair of high-definition lenses.
Wow.
Suddenly, the universe is coming into focus in a whole new way.
Okay, this is all incredibly exciting.
Yeah.
But let's be real. If this model is so groundbreaking, why haven't we heard more about it? Why isn't everyone talking about the end of dark energy?
Well, for one, still very new research. It takes time for these ideas to spread, for other scientists to scrutinize them, to test them, to see if they hold up. That's how science works. It's a process.
Yeah.
A constant back and forth, a conversation between researchers' data and theories.
So it's still early days and there's a lot more research to be done.
Right.
What kind of research are these scientists planning next?
Well,
what are the next steps in proving or disproving this model?
They mentioned something called peculiar velocities in their paper.
Okay.
Remember how we talked about galaxies having their own little movements within the cosmic web? Those movements on top of the overall expansion are called peculiar velocities.
Right. Like each galaxy doing its own little dance?
Yeah, exactly.
So how do these peculiar velocities fit into the picture?
They think that accounting for these peculiar velocities in their analysis could further strengthen the case for the timescape model.
So they're being super thorough, making sure they've dotted all their I's and crossed all their T's.
Exactly. They're not jumping to conclusions. They're meticulously analyzing the data, considering all the possible factors, and that gives their findings even more weight. And that's the kind of rigor we want to see in science, right?
Absolutely. It's all about being careful, being precise, and being willing to let the data lead the way.
Yeah.
But even with all this meticulous research, there's still a chance they could be wrong, right?
Of course, that's the nature of science.
Right.
It's always a work in progress. But even if the timescape model doesn't turn out to be the ultimate answer, the questions it raises the possibilities it opens up. They're incredibly valuable.
So even if we're not saying goodbye to dark energy just yet, this new research is pushing us to think differently about the universe, about its expansion, about its very beginnings. It's making us question our assumptions and look at things with fresh eyes.
And that's what's so exciting about science.
Yeah.
It's not about being right or wrong. It's about the journey, the exploration, the constant quest to understand the universe and our place within it.
Yeah, it's like we're standing on the edge of a new frontier, looking out at a universe that's even more complex and awe-inspiring than we ever imagined.
And that's the beauty of it all, isn't it?
Yeah.
We're constantly pushing the boundary of our knowledge, discovering new things, challenging old ideas.
And who knows what other incredible discoveries are waiting for us out there.
Right.
I mean, so the research is just one example of how our understanding of the universe is constantly evolving.
Absolutely. And this particular research, you know, regardless of whether the timescape model becomes the new standard or not, it really highlights how important it is to keep questioning keep exploring, and never be afraid to challenge the status quo.
Yeah, it's a good reminder that even in science, which is all about facts and evidence,
Right.
there's always room for creativity, for new ideas, for thinking outside the box.
Exactly. And sometimes those out-of-the-box ideas, they lead to the most profound shifts in our understanding.
Yeah.
Just like this Timescape model.
Right.
It challenges us to reconsider some of our most fundamental assumptions about the universe.
So for all of you listening out there, the next time you look up at the night sky, remember this: the universe is a vast and mysterious place, full of wonders that we're only just beginning to understand.
And who knows, maybe one of you will be the one to make the next groundbreaking discovery, the one to rewrite the textbooks, the one to unlock the secrets of the cosmos.
Keep looking up, keep questioning, and never stop exploring.